everybody, and welcome back to Database Management. In this module, we will be talking about Boolean operators and aggregates, all of which are part of advanced SQL queries. Here's what we're going to learn in this module. First, we will look at the where statements that we have already encountered, and then we will practice them with Boolean operators and, or, and not. After that, we will learn how to group data and perform mathematical operations on them. We will learn how to use functions like count, sum, average, and other arithmetic operators. Let's get started on the Boolean operators first. Here we're seeing an example of a simple SQL query. Select column 1, column 2, or however many columns you want from the table with the table name, followed by a semicolon. In our example, we are selecting movie ID, movie title, and year produced from the table called movie, and we're ending our query with a semicolon. And then, as you can see below, we're seeing all of this output of 20 movies. But what if I want to constrain my output, that is, filter the rows that show up on my screen? For that, I can use the where operator, because where constrains my search output based on the criteria that I specify. Here we are seeing a number of ways in which I can use the equal sign, greater than, less than, between, and like with the % wildcard for a string search in order to constrain my search output. Here we're seeing the same select query as before, but now with different where clauses to constrain our output. These where clauses have different complexities. First, we're going to use the like operator with the string wildcard %. So here we're seeing where movie title like the, and then the %, which means we're looking for all the movie titles that start with the word the, and our output gives us these 6 here, all movie titles that start with the. Now we're going to make the query a little bit more complex, and we're combining our like and our string search with a date constraint, and we're going to say and. We're going to use and. So here we're saying where movie title like the, which is what we had before, but now we're adding and year produced is greater than 2006. And if you look at the example from above, movie IDs 10 and 11, The Departed and The Lake House, were both produced in 2006, and also The Devil Wears Prada, that's movie ID 16. And in fact, now our output shows us only 3 of these movies, namely The Dark Knight, Curious Case of Benjamin Button, and The Bucket List, and all of these were produced later than 2006. We can also constrain our output for movies that were produced in a year that is less than or equal to 2006. And we know that our movies 10, 11, and 16 were produced in 2006, so our output here shows us the movies that were produced in the year 2006, which is smaller or equal to 2006. Lastly, we are going to look at not like. Now, not all of our movies start with the word the, so we can, in fact, by using not like, pick up the movies that do not start with the condition that we specify. So here we're seeing all our movie titles that, in fact, do not start with the. but that are still produced in the years before 2006. Let's take a look at our Boolean AND. Here you're seeing the query where we are looking at the customer last name, the movie title from our transactions table, where the customer last name starts with STE and where the movie title equals Superman. Now, this is our transactions table. Are we going to see Stevens and Superman? What about Fuller and the Notebook? Probably not. But here we have Stefan and Batman. Reddy and Superman? Maybe. Stevenson, Red October, Al-Hanash and Superman? Steiner and Superman, we know that we're probably going to see that. But what about these three here? What do you think? And the answer is, we're going to see only the first and the last row. How does our Boolean OR behave? If we look at this query here, select customer last name, movie title from our transactions table, which is what we see here below, where the customer last name starts with STE, or the movie title is Superman. Will we see Stevens because the movie title is Superman? What about Fuller and the Notebook? Stefan we have here, and the movie title is Batman. And here we have Reddy, and the movie title is Superman. Stevenson and Red October? What about Al-Hanash and Superman, and Steiner and Superman? Which rows do you think we will see based on the conditions in this query? And the answer is, we will see rows 1, 3, 4, 5, 6, and 7. Why is that? Because only one of these conditions needs to be satisfied. So let's talk about the Boolean NOT, which we see here as a bang. Our query is selecting the customer name and the movie title from the transactions table, and our where clause here directs us to filter by the customer last name that starts with STE and the movie title that is not Superman. So will we see Stevens with the movie title Superman? How about Fuller and the Notebook? What about Stefan and Batman? Or Reddy and Superman? Or Stevenson and Red October? What about Al-Hanash and Superman? Or Steiner and Superman? All based on this filter, this constraint that we've set up in the where clause. Take your guess. And our output will show us only rows 3 and row 5. Because we are looking for a customer last name that starts with STE. That's Stefan and Stevenson. But the movie title cannot be Superman, and here we are connected with an AND operator. And here, row 3, Stefan is watching Batman, and Stevenson is watching Red October. So these are the only 2 rows here that satisfy this condition. When we talk about the Boolean not operator as the bang, we need to understand when that is actually used as the bang and when it is used as the word not. So in a regular where statement, where we are working with an equal sign, right here, we use the bang, so not equal. However, when we are working with a like statement, we use the word not. So in other words, the bang does not negate the like operator. Another way we can work with our output is to sort it. When we sort our output, we will use the order by operator and we will specify the column by which we want to sort. Here you're seeing an order by year produced, and in our output, the output is ordered by the year produced. We're seeing it starts with the earliest and ends with the latest year. So the default for the order by operator is ascending. If we want to order our output by the highest, starting from the highest year produced and going to the lowest year produced, then we will have to specify descending. Descending means we are starting with the highest value, and the rows that contain the lowest value by the column that we select appear at the bottom of our sort.
We want to do more than just retrieve basic information from our database though, right? So we want to do math, and we want to see how we can use logic in order to derive more meaning, more information from the data that we have. That's why we use aggregates. Aggregate functions help us make basic mathematical sense of the data that we have in our database. We can use aggregate functions to do basic business analytics. Aggregate functions are, for example, average, count, max, min, sum, and round, with which we can round the output from our math to 2 decimals. Here we're seeing an example. We are working with the movie rental table from our movie stream database. We're here selecting the movie ID, the sum of our rental fee, the count of all the rows that we have in this movie rental table, the average of our rental fee, and we're getting all the data out of our movie rental table. So we're seeing here our movie ID. It picks up the first movie ID that we have, all the rental fees that we have in our movie rental table. We have 20 rows in this movie rental table that appears here in this column. And then the average of our rental fee is here calculated. What we're seeing in these columns here, in contrast to this, is the magic of the alias. This second line of our query is special, as is the third line, because we are renaming the header of our table field here with a new one. Cum rent really is the sum of the rental fee times rented is really the count of all the rows that we have. Normally, the header of the row would appear as just the basic mathematical operation, which we're seeing here, average rental fee. But if we rename it with as, and then the expression afterwards, it appears aliased, meaning the expression after the as becomes the new table header. That's what we're seeing here with cum rent, and that's what we're seeing here with times rented. Here we're seeing the query that we've run previously in order to get our movie ID, the sum of all rental fees as the cumulative rent, the count of all the rows in our movie rental table as the times that movies have been rented, and our average rental fee per movie from our movie rental table. But we're also seeing that we get that information for the entire table. What if I want to get the same information but for each of our movies? This is where the group by clause comes in very handy. As you're seeing here, we have the same query as we have to the left, but our last row here says group by movie ID, and that's how the magic happens, because in this output we are performing all the same calculations, namely the cumulative rent, the times rented, we're counting the rows there, and the average calculation, but this time no longer applied to the entire table, but split out by movie ID, because group by allows us to create subtotals. Simple arithmetic is another way in which we can aggregate our data. Our arithmetic operators that we have available in MySQL are addition with plus, subtraction with minus, multiplication with the asterisk, and division with the forward slash. We can also use the percent sign to do modulo math. Here we have some examples. We use the select command in order to introduce anything that we're doing on the command line. So we say select and then 1960 plus 55 as current year. Note the use of our alias here. So our current year will be 2015. Now we can do our subtraction with select 2015 minus 1960 as husband underscore age, and then we know how old the husband is, namely 55. We can also compute our Netflix annual cost by multiplying the monthly cost, $7.99 times 12, but we do need the select command. So we can say select 7.99 times 12, and then we use, again for convenience, our alias as Netflix underscore annual underscore cost, so that our output will read Netflix underscore annual underscore cost is $95.88. We can also use our division by using select and then our divisor in the dividend, 99 divided by 12 as Amazon Prime monthly cost, and then MySQL will do the math for us, again with our alias here, which we can use, we don't have to, and the Amazon Prime monthly cost comes out to 8.25, but we're seeing here we have those 2 zeros here, and that's really not the kind of financial math that we want to do. So instead of leaving the output as it is here, we're going to round that. So we apply the round function to it, and we say select and then round and then open and close paren here, 99 divided by 12, then comma, and then the number of decimals that we want. That is 2 for us because we're doing financial math, as Amazon Prime monthly cost. And because of the round operator here, our Amazon Prime monthly cost comes out to 8.25. That's the rounded version of the 8.2500 that we have above here without the round function. Here is what we have learned in this module. We have practiced where statements with the Boolean operators and or, and we have learned how to use not and when to use just the bang. We have also learned how to group data and how to perform mathematical operations on them. So we've used count, sum, and the basic arithmetic functions. Thank you for listening, and I look forward to seeing you in a future module.